Okay, today is December 13th, 2011. We're on lesson 7.4. Now, in the past, we covered similar triangles and the tangent ratio. Today, we're going to work on both the sine ratio and the cosine ratio. What I've done is I've put the formulas right here, and underneath, I've set up triangles to help you with them. Now, it's important to realize the very first one, sine theta. Theta is referring to our angle. Okay? So in this question, I'm talking about this angle in the top left here. It is equal to the opposite side of the triangle divided by the hypotenuse. So I showed you where this is the opposite and this is the hypotenuse. Now, using that same triangle, if I'm looking for a different angle, the other side of the triangle becomes the opposite, but we still have the exact same hypotenuse. A hypotenuse never changes in a right angle triangle. Okay? Very important, actually we put that down, that these are all right angle triangles. Okay? So these are all right angle triangles. So we've set it up where depending on the angle we're looking for, the opposite side of the triangle changes. Okay? And that's for our sine. Now for our cosine, or you guys see cos, the same angles, we would use the adjacent side of the triangle. Okay. The adjacent side of the triangle is the side touching the angle that's not the hypotenuse. So again, the hypotenuse is still the same as it was with our sine ratio. That never changes. Our adjacent side becomes the vertical side in our first question. And then in our second angle, the adjacent side becomes the base, or the horizontal line in the triangle. Okay, so I've written what I think it's considered an acronym, SOHCAHTOA. And what that stands for is a quick way to remember our formulas. Our sine formula, we'll put underneath. Our cosine formula. And our tangent formula. So, what those refer to is S stands for our sine theta, whatever our angle is equal to the opposite side divided by the hypotenuse. They call it SO. That's OH, okay? Sine deals with opposite and hypotenuse. Our cosine theta is equal to the adjacent side, which is our A, divided by our hypotenuse. And finally, tangent theta, our t, is equal to the opposite side divided by the adjacent side. So this is a quick way, I think it's considered an acronym, in order to remember our formulas. Okay, you need to know all three of these formulas for your test on Friday. Okay. In this question, example 1, what we're going to do is we're going to set up the three formulas. Okay. So let's set it up. We have our sine ratio, cosine ratio, and our tangent ratio. Okay, I'm going to set up all three of these in this triangle. Very important in order for this to work is our theta is over here. Okay, our angle. And what we'll do is we'll compare it to when the angle moves, how this changes the question. So the first thing we're going to set up is our sine ratio. If you guys recall, we end up with sine theta is equal to the opposite over the hypotenuse. So, in this case, what side is our opposite side? 10. This is our opposite side. So our hypotenuse in this one, let's see if I can get that. Our hypotenuse in this question will be the 26. Okay? So in that case, what that means is sine theta is equal to our 10 divided by 26. Okay. In our next question, we're going to deal with our cosine law. Sorry, not law, ratio. So we take our cosine ratio, and in this one, it's dealing with the adjacent side. So right now, the only side of the triangle I haven't named is the adjacent. Which would it be? 26. 24 is going to be our adjacent side. So in other words, we're going to end up with cos theta is equal to our adjacent side, 24. Our hypotenuse, though, is still 26. So 24 divided by 26. Okay. Finally, our tangent. Our tangent theta is our opposite over our adjacent, which we have the formula over here. Okay. Our opposite side is the one in red, which is 10. And the adjacent side is our 24. So tangent is 10 over 24. So I want you guys to recognize a few things here. All three of these ratios deal with different numbers. Okay, none of them are the same. Sine is opposite over hypotenuse. Okay. Cosine is adjacent over hypotenuse. Hypotenuse occurs in both the sine and the cosine. And tangent is opposite over adjacent. Opposite occurs in sine and tangent, and adjacent occurs in cosine and tangent. Okay? So it's very important that we know how to set these numbers up. Now, I'm going to quickly change the triangle a little, and I want you guys to try and figure this out. Okay. Example 2, I took the exact same triangle, but I changed where the angle was. Now, because the angle has changed, several parts of the triangle have also changed. What is now my opposite side? 24. Okay? Now in these ratios, where are my opposites? Where can I fill the in? I can do the numerator of sine, which would be 24, and the numerator of tangent. Both deal with the opposite side. So we have that. Adjacent side. What would my adjacent side now be? 10. So our adjacent sides are in cosine and tangent. Numerator of cosine is 10. The denominator of tan is also 10. Okay? And finally, we're left with our hypotenuse. Our hypotenuse in this question is still the exact same. Our hypotenuse is in sine, 26, and in cosine, 26. Now, what I want to draw attention to, I know they're a bit far away, but we have sine here, and if I can, it's 10 over 26. Drag this down. I want you guys to notice, well, that's going to take too long. Okay, that was going to take too long, so I want you guys to realize our sine, we had 10 over 26 on the other angle. On the new angle, we have 24 over 26. Okay? In our previous question for cosine, we had 24 over 26. We now have 10 over 26. And in our tangent, we had 10 over 24. Now it becomes 24 over 10. So we're going to talk about the relationship here. If you notice, the original sine, when we changed the angle, now became cosine, because the opposite and adjacent sides switched. Our original cosine, when we were looking for the other angle, became the new sine, 24 over 26. And our tangent ratio flipped, 10 over 24 to 24 over 10. It's important you guys realize the relationship between the angle and the ratios. Example 3. Example 3 says, Captain Jack is navigating his ship to Port Harbor, which is directly north of the ship's location. So we got a boat. Okay? So we have our boat, and the port is directly north of the boat. So you know it's directly straight up from it. Here's our port. Okay? It also says to compensate for an easterly current, he aims for a point on shore that is 5 kilometers west of the port. So we're going to put an arbitrary thing here. This is 5 kilometers west. You guys need to know your directions. There you go. That's north, that's south. So west is our point here. We've gone to west, and we know that this distance is 5 kilometers. Okay? Assuming that the point on shore is 20 kilometers from his position now, so they're saying his position now is 20 kilometers away from the point he's aiming at. Created the triangle. At what bearing must Jack head the ship? So, what they want us to find is essentially this angle here. Okay? This is the bearing. Now, normally bearings, if you guys recall, if you guys remember, a bearing is technically clockwise of north. So really, they kind of want this angle, but in terms of our questions, I'm just going to ask you what that angle is. So we need to solve for this angle here. Very important. I got to figure out what sides of the triangle I have. I know this will be my theta or x, whatever you want to call it. My 5 kilometers is considered what part of the triangle compared to my angle? That's right, this is our opposite. And our 20 is considered what part? That's right, it would be considered the hypotenuse of the triangle. Okay, so from our ratios, I have an opposite and a hypotenuse. Which of the 3 ratios would I be using? That's right, we use our sine. Okay, that's right, it would have. Our sine theta. Our opposite side is 5 kilometers. Our adjacent side is 20 kilometers. Okay, I can divide those two. 5 divided by 20, 0.25. So we have sine theta is equal to 0.25. Now remember, in order to find an angle, I got to move sine to the other side of the equation, where it becomes the inverse. So we have theta is equal to sine inverse 0.25, which means I'm going to have to shift on the calculator here. Sine inverse, I keep my number up, 14.4. 4 degrees, okay? So, in terms of what I'm asking you, this theta here is 14.4 degrees. Now in the book, I think they wanted the bearing. Oh good, they didn't tell you it the other way. So it's approximately, we could round this to 14 or 15 in terms of whatever you guys want. Technically, if we round it, it comes 4.7. We'd round up to technically 15 degrees. Okay? So he's approximately headed 15 degrees northwest in this question. He's heading upwards, which is north, and to the left from where he is west. Okay? Okay, example 3b. In this question, Captain Jack, okay, he's above water in this question. Clearly he's on a boat. And it says that Jack is in communication with a submarine that is cruising at a depth of 400 meters below sea level. So this submarine, we know, is 400 meters below sea level. So that means, in terms of directly below him, that's 400 meters. Okay? He's communicating with a submarine that's at least 400 meters below him. We don't know how far it is. If Jack's radar tells him that the submarine is 500 meters from Jack due north of his ship. Okay? So let's assume now that north is this direction. He's 500 meters north of him, this submarine. Okay? So we have our submarine here. It's got its telescope. They're in communication. What the question is trying to tell us, guys, is that the submarine is actually 500 meters away from Jack. It's in a direction of due north. So what it means is the distance between the two of them is 500 meters. Okay? So the distance between the two of them is 500. The submarine is 400 meters below sea level in this question. At what angle is the submarine located with respect to Captain Jack's ship? So again, they're looking for this angle. At what angle are they sending, I guess, signals at each other? Okay, so we got to define the sides of the triangle we have. 400 would be considered what side of the triangle relative to our angle? This is the adjacent side. Okay. And what would 500 be considered? That's right. This would be our hypotenuse in the question. So we're going to set up which of the ratios? Cosine. So using our cosine law here, or ratio, I keep saying law. This means cos theta is equal to, our adjacent side is 400, our hypotenuse is 500, 0.8 cos theta. To solve for the angle, we got to bring cos to the other side. Just the same way we did tangent. It's going to become the inverse. So we get cos inverse 0.8. So we get 0.8. Cos inverse 36.86. So our angle is 36.86. And they told us to the nearest degree, so we would round this angle to approximately 37 degrees. Okay? So this angle here is approximately 37 degrees in our question. Homework, page 372, 110, 12, 15, 30, and 32 are chapter problems.